can. I will not apply natural log to it. You can. I will just use the quotient rule. So y prime. I will write 3x plus 4 to the 8th power in the denominator because I have to square the denominator. So if you want, we can write it in 2 steps. The first step would be 2x minus 5 to the 3rd prime times 3x plus 4 to the 4th. And I don't need that. 2x minus 5 to the 3rd. And then 3x plus 4 to the 4th prime. I normally don't write this step, but I think it's useful for you to see it. Okay, so now I apply the chain rule here and the chain rule here. So, bring down the power, subtract 1 from the power, and multiply by the inner function prime. So 1, 2, 3 pieces come from here. Then I multiply by 3x plus 4 to the 4th. And then minus 2x minus 5 to the 3rd. I bring down the power. I subtract 1 from the power. And I multiply by the inner function prime. Well, you must be proud of me. For the first time, it fit in one row. Thank you. Thank you. You're very kind. Okay, so now, are we in agreement with this step? Everyone? Are we in agreement with this step? Yes? Okay, now we see 2 common factors in both terms. I see a 2x minus 5, and also a 2 and a 3, right? A 2 from here and a 6, right? 6. So 3 and 2, and from here a 2 and a 3. So 6. 2x minus 5, I'll come back to the power in a minute. And 3x plus 4, I'll come back to the power in a minute. And then 3x plus 4 to the 8th power. Ready? Okay. So, this is power 2 and this is power 3, and I have to choose the smallest, which is
2.
Very good. This is power 4 and this is power 3, and I have to choose the smallest.
3.
Let's see what is left from the first term. 6 is completely out. 2x minus 5 squared is out. From these 4, I removed 3 of those, so 3x plus 4 is left. And then I reach the negative sign. Is this okay, everyone? Now I have 12 there, 4 and 3. 12, and I took out a 6. So a 2 is left. 3x plus 4 cubed are all out, but from this power 3, I only took out 2 of those. So there is, in parentheses, a 2x minus 5 left. Is this okay, everyone? Yes? At this point, and only at this point, I can do this. I remove 3 factors, identical factors on the top and 3 from the denominator. Everyone okay? And you have a question?
Yeah.
Okay, no, I'm sorry.
And you had to simplify.
Yeah, I have to distribute them. Yes, of course. Of course. Yes, Greg?
So you did 3 times 2 and pulled that all the way out.
Correct. Because
So-
there is a 6 there and a 6.
Right. And then for the 2x minus 5 and the 3x plus 4, you took the smallest exponents. Are you working the left side of the problem, and then you're going to work on the right side with that minus sign? Or is it just all?
So, no, from this piece is left. Because everything else is out.
Okay.
Minus, from this is left.
Gotcha.
Because everything else is outside.
Gotcha. Okay.
Better?
Yeah.
Okay, so then we have 2x minus 5 squared, and this is 3x plus 4 minus 4x and plus 10 over 3x plus 4 to the 5th power. And finally, I have 6, 2x minus 5 squared, and this is minus x plus 14. And you will see in chapter 4 why. Please factor out negative 1. Negative 6, 2x minus 5 squared, x minus 14 over 3x plus 4 to the 5th power. By doing this, we are making our life easier in chapter 4, because we will be able to find the x-intercepts very easily of this function. I should say the critical numbers. Okay, moving on. Any questions? Is this okay?
Mm-hmm.
So please remember, do not simplify in a sum. I've seen it before, that's why I'm saying. In this stage, when you have a term minus another term, you cannot simplify these two, or simplify these two, or whatever else you can do, please. Is that okay? Okay, perfect. So moving on to our particle now. So we have f of t, negative 6t cubed, plus 36t squared minus 54t. We want to find the velocity at time t. That's our first question. Of course, t is greater than or equal to 0. Please put it in. I forgot to put it in. My apologies. So obviously this is f prime of t, which is
Negative 18 t squared plus 76 t minus 54.
72t and minus 54. Very good. Perfect.
Or 72, yeah.
That's okay. When is the particle at rest?
Did you plug in 0?
Careful. When the velocity is 0, particle is at rest. I don't know the time, so we're asked to find the time. We cannot plug it in, right? So we're asked to find the time when the velocity is 0, when the particle is at rest. Okay, so then negative 18 t squared plus 72t minus 54 equals 0. First of all, you should also always refuse to solve a quadratic equation with a negative leading coefficient, and I'm hoping that I can get rid of the whole thing. I'm hoping. Let's take a look. T squared minus 4t and plus 3. And of course, this is way more human than the previous one. And I'm also hoping that I can factor quickly. It's quadratic, so obviously I'm expecting 2 solutions. If one is negative, then I will disregard it, of course, but if both are positive, I'll consider both. So how do I factor this?
T minus 1, t minus 3.
So it's 1 second and 3 seconds. I know that this kind of problem will request that table, so I'm going to get it ready. With the velocity, of course, eventually the acceleration, and action, whatever the particle is doing. So eventually we're going to be asked. So I will put 0, 1, 3, and infinity. I will put 0 for the velocity. And I will also study the sign so I know when the particle is going from left to right and when the particle is going from right to left. Going to the right will always be positive, going to the left will be negative. Going up is positive, going down is negative. So, plug in 0, in the actual velocity. This is the actual velocity function. This is where I plug in 0 to get the sign here. So when you plug in 0 here, what sign do you get? Very good. When we plug in 2, what do we get? I want to plug in 2 in here to get the sign. Okay. And when I plug in 10, what do I get? Of course.
You're plugging those numbers into the velocity.
Yes, because I'm studying the sign of the velocity.
Okay.
Thanks to infinity, not just this.
I didn't read that part first yet. So now when we get, it says 6 seconds, so we're going to have to change this into 6. Find the total distance traveled by the particle during the first 6 seconds. How do I determine the total distance? The absolute value of f of 1 minus f of 0 plus the absolute value of f of 3 minus f of 1 plus the absolute value of f of 6 minus f of 3. Let's put the function in. In y equals clear, whatever you have. And the function is -6 t cubed plus 36 t squared.
You missed an operator.
I put the plus, didn't I? Minus 54t. In second and table, I want 0, 1, 3, and 6. Now I copy f of 1, the absolute value of -24 minus 0, plus f of 3, 0 minus the absolute value of f of 1, which is plus 24, and plus f of 6, which is -324, minus f of 3, which is 0. So -24 minus 0 plus 0 plus 24, the absolute value. Why do we do this? It's because the particle, no matter which direction it's going, it's accumulating distance. That's why we study the sign of the velocity. So we know where to break it up into and how many pieces. So this was 24. This is 24. And this is 324. 324. So 324 plus 48, I got 372. And the measurement unit, please don't forget meters. So the particle covered 372 meters in the first 6 seconds. So now find the acceleration at time t and when the velocity is 0.
So
Yes?
I know you have to do the first 6 seconds, but how do you know to do the 1 minus 0, 3 minus 1? And
Very
6 minus
good. Because this is what it says. The particle starts at 0, but goes to your left. A second later, turns around and goes to your right for 2 seconds. And then when at second 3, it turns around again, and for 3 more seconds goes the other way.
Based on those points that we plugged
Both
in.
on those points, the
Okay.
velocity, when its velocity is 0, and when the velocity changes sign.
Gotcha. Okay.
So between 0 and 1, yes, between 0 and 1 goes this way. Then between 1 and 3 goes this way. Between 3 and 6 goes this way. So we have to add those pieces.
Okay.
Other questions? Yes, Eddie?
So it is measuring the total distance that
Yeah,
you
correct.
leave from,
Yes.
not just
From
the
0 to
circle.
1, from 1 to 3, and from 3 to 6. So this is the distance between 0 and 1. F of 1 minus f of 0 is the distance between 0 and 1. F of 3 minus f of 1 is the distance between second 3 and second 1, basically between second 1 and second 3. But I have to start with the second one. And here f of 6 minus f of 3. Is that okay? So now we find the acceleration, a of t, which is, I'm looking here now, negative 36t plus 72. Negative 36t plus 72. We're asked to find the function, which we did, and then we're asked to find when the velocity, the acceleration when the velocity is 0, which means at 1, and at 3. In order to put it in the table, I also have to find where the acceleration is 0. Not just these two that are asking us, but also a of t is 0. How many seconds after the starting point is a of t 0? Negative 36t plus 72 equals 0 means t equals 2 seconds. Do you agree with 2 seconds? Negative 36 times 2 minus plus 72 is 0. So a of 1, I hope you agree, is 36, and the measurement unit, crucial, second squared, very good. And a of 3, very good. So then, when t is 2, the acceleration is 0. What is the sign of the acceleration? Before it's 0. Yes, because it's a linear function with a negative slope. Very good, awesome. That's all you need to do, or just plug in 0, it doesn't matter, really. Good. So now we're asked for an action. See what happens, on which intervals is this particle slowing down or speeding up. So we look at the first interval. The two forces, velocity and acceleration, are not helping one another. Slowing down. Now they are helping one another. Now they're not. And now they are. I did not use the correct, I didn't have enough of a course to write, so we should have written slowing down, speeding up, slowing down, speeding up. So please correct that, put that in.
How did you?
Yes?
Uh,
Determine this.
Yeah.
Okay. So I'm riding my bike. The maximum I can do, let's say, is 20 miles an hour. I can't exceed that. So I'm doing the maximum, but I have a tailwind, 5. What is my actual speed?
15 or 25?
25.
Oh, tailwind, yeah.
Right?
25.
So now let's say I have a headwind, and all I can do is 20, but I have a headwind of 5. What is my actual speed?
15.
The same thing here.
Okay.
So if these two forces, which is the velocity, which are the velocity and the acceleration, they are working against each other, they are slowing down the particle.
Okay.
Like me on my bike and the headwind. The wind does not work with me, it works against me. So it's slowing me down.
Right.
I can do 20, but not anymore because of the headwind.
Gotcha.
So when they have the same sign, they're working together because they go in the same direction. I go from left to right, and the wind goes from left to right with me.
Gotcha. Okay.
Okay, is that clear? Okay.
I had one more question.
Yes, please.
So it said when velocity is 0, you plug in 1, but where did we get the 3?
Remember, we are asked to find the acceleration when the velocity is 0, and velocity is 0 at 2 points.
Oh.
When t is 1 and when t is 3, that's why we plugged in 1 and 3.
Okay, I got you. All right,
Better?
Yep.
Good. Other questions? Okay, so let's look at limit as x approaches 0 from cosine 3x sine to 12x over 4x.
36 still.
Say it again. Okay. I guess Kristen's telling me 1 minute. When you go through the material and you yes, please, Noah.
I just had a question.
Yes.
If I
Yes.
explain this question, since we're number 5.
Yes.
It asks you to explain the meaning. I was just wondering if that's
The rate of change when 100 units are produced, the rate of change, the rate of change of cost per unit, when 100 items are produced. The rate of change of, we did that problem together. So the rate of change of cost per unit when 100 units are produced. And it's also predicting the cost of the next item, the 101st one. It predicts the cost of the 101st item. So that is an estimate because we use the derivative. It's the dy instead of the delta y. Remember, like with all limits, you have to figure out what type of limit this is. Because if you plug in 0 and you get 15, you're done. You don't have to do anything. That would be nice, right? So I have to plug in 0 and I do get 0 by 0. If you attempt to use L'Hopital's rule on this, there would be a tragedy. Because you will always get a sum of a product, of 2 products, I'm sorry. It's a product, and you have a sum of 2 products. And then if you apply it again, you will have a sum of 4 products. And then if you apply it again, and on and on and on. Instead, let's say, what happens to this piece when x approaches 0?
1.
Yeah, so this is not a problem. I'm not saying to delete it from there, but it's not a problem. That is not the culprit that creates 0 by 0. That's a friendly function cosine around 0. It's 1. So now I think in terms of box, box, box. There's nothing I can do to change the argument inside of x, of sine. I can't do that. But I can make this into a 12. How can I make that into a 12? But I cannot just multiply the denominator by 3. I have to multiply top and bottom by 3. And of course, 12x is the same thing. If x approaches 0, 12x approaches 0. So this piece now, and this piece, and this piece are all identical, and they approach 0. So therefore, this approaches what? Yes, this approaches 1, what is left over? So this is not a good idea to apply L'Hopital's rule.
It would work.
But if
right?
it's a sum,
It would work, right?
eventually.
Okay. Would you just take the first derivative bottom equal 4?
Okay, and then we'll, yeah.
Alright.
Fine, but if you have a product at the top and you have a product at the denominator, I just wanted to point that out, but you're right, because the denominator is just a linear function.
Would we get points deducted on the test? if we
No.
use L'Hopital's rule?
No, of course not. Of course not. The point I was making, I wasn't even looking at the denominator to tell the truth when I said that. I just said, be very careful with the product. If you have 2 products, then we'll go on forever. Because you'll always have the sum of 2 products, and not the sum of, yeah. So in this case, yes, you're right. I wasn't looking at the denominator. So any questions on this? Any questions? Okay, so I think we finished this handout, right?
Number
Okay.
6.
I can write it down if we did it.
6? What do you mean 6? The last one?
For
We did
number 6, the tan
Oh, I'm
degree,
thinking.
we're using differentiables.
Oh,
Number
of
6 on
course.
page 7.
Yes, we didn't do that last time because we didn't. Okay, yes, I'm sorry. Sorry.
Page 7.
I forgot about that one. Good, very good. So here we have a tangent of 3 degrees. And we should immediately write f of x plus f prime of x dx. We're asked to use differentials. I have to identify the function, I have to identify x, I have to identify dx, and determine f prime. And then everything is done. So, f of x, please.
Tan x.
X. Exactly, that's all I know. That's the closest I can get to 3 degrees. Very good. F prime of x. Very good. Dx. Right. But remember, in here, it must be in, so which is 3 times pi over 180, or pi over 60. This piece, inside tangent, it doesn't matter if you plug in degrees or radians. The answer will always be the same. But if it's outside, you cannot use degrees. So let's put everything together. Now I can write the equal symbol. This is okay. This is not okay to write the equal symbol here. But from here, I can write the equal symbol and continue. Tangent 0, please.
0.
Perfect. Plus f prime of 0.
1.
Very good. Times pi over 60. So the answer is pi over 60. You don't have to do anything to it. Yes, I would recommend make sure that this is okay, so plug it in. So I will. I will make sure that the mode is in radians. Well, for tangent is in degrees. That's fine. So that's okay. Let's leave it for now for a second. So that is okay with 3. That's fine. But now, oh, I don't have any, so that's fine. So it's pi divided by 60. Any questions? Yes, no?
Now, just to understand dx a little bit more, so
Yes.
if it was tan like 40, would the dx be negative 5?
Yes.
Right.
Yes. However, from 45 to 40, because it's degrees, it's not going to be a big error, right? But it depends on the function.
So it's just from like x to dx is, if it's, or
Yes.
dx is from
Yeah.
x
So you have to
whatever
use, because we are doing basically this by hand, right?
number.
So we have to use the closest you know.
Gotcha.
So if I have a sine of 89 degrees, of course it's 90 minus 1. If I have a cosine of 46, it's 45 plus 1. Yeah, the closest to the ones I know. Otherwise, I'll have to use a calculator. Yes, Greg, go ahead, please.
So you plugged in 0 for the secant square, and that's how you got the 1?
Yes,
Okay.
because secant is 1 over cosine, and cosine at 0 is 1.
Okay.
So 1 over 1 will be 1.
1. Okay.
So what I would like you, I'm going to choose another few problems. We have about 9 minutes left. So what I would like you to do for Thursday is review everything and come back with a list and say, I need to see 2 more problems of this kind. I need to see 1 more problem of this kind. I need to see, because if you don't say anything, then I'll start chapter 4. Why? Why? It's because I'm always afraid of November. Why am I afraid of November? Because we only have 3 weeks in November, right? And a half. 3.5, right? Because of Thanksgiving. So that's, and I don't want to present new material on the last week of classes, and I don't want to have a test on the last week of classes when we have to review everything. The other thing that I'm kindly asking you to do, moving forward, every weekend, I said that, please set aside time to redo the previous tests. You have them with solutions posted. So please redo every weekend. Say, I need 2 hours to review the previous test. I need 2 hours or 3 hours to review now, moving forward, the first 2 tests. Later on, the first 3 tests. Because when you get to the final exam, you're not gonna have any pressure. You're gonna know everything. But if you don't, in another month, you're gonna forget a lot from test 1 and a lot from test 2. And then you're going to start from scratch. And we don't want to do that because it's, I'm sure you have other classes that you are taking. Okay, so a few more minutes. So what would you like me to choose now, or you choose? Any particular type of problem that you would like to go back to?
Do the derivative of hyperbolic function.
Okay, very good. So that is from section 3.11. And also chapter 4 is huge. It has 10 sections. And also chapter 5. Chapter 5 is not huge. It only has 5 sections. However, it requires a lot of work. Okay, hyperbolic. On page 263. Let's look at 30. Is it? I'm looking at the time on the computer, so.
The second hand is.
Oh, yeah, it just stops every now and then.
I think it's probably running out of battery. E to 2x. It's something like this you have in mind?
Sure, perfect.
Okay, so we want to differentiate this function. So let's take a minute and then I can find something else.
So they're using the product rule, right?
This is not the product rule. Tangent is outside of this, which is 1 plus e to 2x.
So it'd be the secant squared
Secant
h
squared of, yes.
of 1 plus e to the 2x.
Yes. Make sure that you put the power after h, not before h.
And then you would do
Of 1 plus e to 2x, now times the inner function prime, which will be e to 2x, but times
2.
2.
Gotcha.
Okay. Okay. Now what about 40? F of x equals hyperbolic sine of tangent x. So f prime of x is, yes, hyperbolic cosine of tangent x times the inner function prime, which is secant squared x. Okay, well, we can stop here if you'd like. If you have anything else, we can continue, of course. Yes, please, Eddie.
So, on number 30, you put the squared after the hyperbolic, but on 40, but it's before the x line.
Say that again.
So secant h squared.
This one, because it's the inner function prime.
So secant